Introduction. Hello everyone. In this video I will walk you through the Python script that tests a cost function and the gradient computations for linear regression models. This part of programming assignment where we need to ensure that our functions for calculating cost and gradients work properly with different inputs. We will go step by step, covering both the code structure and logic behind it. Let's get started. Explanation of the problems for this. First of all, a quick explanation of that we are doing in typical linear regression model. We try to fit a line to data points. The cost function helps us evaluate how well the line fits the data, and the gradients help us optimize this fit by adjusting the model parameters. We will be testing these concepts today. For cost function tests, compute tests, cost tests. The first part of the code is the compute cost test function. This function is designed to test our cost of function by feeding it different inputs and checking in the results are expected. It tests five different cases where have we different input data and initial parameter values of the weights and BS. For case 1. In the first test case, we have two arrays, and for x equal to 2, 4, 6, and 8, and for y it's equal to 7, 11, and 15 and 19, representing the data points. We also provide initial w equal to and initial b equal 3.0, like this one, and for way this is this one, and the target cost should be 0. It represents this, and because this setup represents a perfect predictions, no errors between the predicted values and actual values. The function uses an assert statement to make sure computed cost is 0. For this, in my code block. For case 2 is this one. The second case uses the same x and y arrays, but this time the initial parameters are initial w equal 2.0 and for b equal to 1.0 is this one. The expected cost here is 2, is like this, and which is calculated based on difference between the prediction and the actual values. The other cases, like case 3, we continue with more test cases, such as using x equal to 1.5, 2.5, 3.5, 4.5, and again 1.5, like this one, yes, and different combinations of weights and BSs. The goal here is to test how our cost function performs with different input shapes and values. For example, in case 3, the expected cost is around 15.32 and 5, like this. Okay, for case 4, in summary, this function checks if our cost function is accurate by testing various cases. If the associations hold true, all tests will pass. If not, we get an error message with details about which tested failed. Okay, and gradient function test like this. Sorry, yes, like this. Next, we have the compute gradients test function. This tests our gradient calculation, which is essential adjusting the parameters in our linear regressions. Gradient tell us in which direction to move the parameters to reduce the cost. For case 1, like this. And here the input arrays are x equal to 2, 4, 6, and 8, and the y equal to 4.5, 8.5, 12.5, and 16.5, like this area. And yes, we start with the initial w equal 2.0 and the initial b equal to 0.5. The gradient for the bs, dg and db is expected to be 0. Okay, like this. And the gradient for the weight dz and dw should also be 0 because this setup represents a perfect fit, like yes, this one. Okay, in case 2, in second test case, the x array remains in same, but we adjust the y array in the initial weight and ps. The expected result of the gradient are dj and dw equal to minus 10.5, like I'm searching right now. Sorry, for case 2, yes. Okay, yes, this one. Okay. These values indicate the direction and magnitude of changes needed to reduce the cost. Again, the function uses assert statement to validate the computed gradients. If everything is correct, we get the message all tests passed, like yes, this is the print function. Okay, and in our code we loop through each data point, compute the model prediction, and the sum of the square differences between the predicted values and the AQ values. Finally, we divide by 2m, where m is the number of data points, to get the average costs. Similarly, the complete gradient function calculates the gradient of the cost function with respect to the weight and ps. This is done by calculating the partial derivative for both the weight and the base. Okay. In our loop, we compute the model's prediction, then accumulate the gradient using the formulas for the partial derivatives. After that, we divide by m to get the average gradient for each parameter. Running the test and conclusions of our next step. And finally, to run the test, we simply call the test function with our cost and gradient function as inputs. And okay, in the next step, I'm run my code. This is my homework codes, and this is our code search. Yeah, I'm showing my code in the first step, and the other steps, all this one is seeing, and right now I'm starting the code and run. I click the run fast code. It's my output for 2 outputs in my code. All test is passed is my first output, and second output again the all test passed. And to sum up, we have successfully right now tested the 2 crucial components for linear regression model, the cost function and the gradient coefficients. These tests ensure that our implementation is accurate and reliable. And thank you for watching, and I hope this explanation was helpful for all my friends and our respectful teacher. Thank you.